Good morning. I guess people are coming into the class now. So today, my plan is talk about the laws of logarithms. There are certain properties very important with logarithm. It's related with exponential functions. Yeah, let's go through some of them. So the first one, we have three here. So the first one is saying log, base A, and the value is A times B. And that means if it's a product of log, inside the log, we can split into addition. Let's see why this is true. Right? So let's rewrite this one. Let's rewrite log let's rewrite it because we learned how to rewrite it, right? Let's see log base A of AB. Let's see this is equals to y. Okay, equals some variable, right? Then we can rewrite this as A raised by y equals to AB, right? Okay, we can write it in this. We can write it in this form. So the first one we can write it in this form. Okay. Then we can write another way. We can write as log A, right? Base little a. Then the value is capital letter A. Let's set it equal to u. It's just some variable, right? Let's just set this term equals to u. Use some variable u. Then let's call log A base A value B. Let's call this V, right? Think this as a V. Or let's multiply these two, right? So the first one we can write as A raised by U equals to 8, right? This one we can write in this form. And the second one we can write in this form. Right? We just change logs into exponential form. So A to the U equals to A to the power of V equals to B. Right? Now let's multiply A and B. Right? We multiply A and B, what do we get? A times B equals to A to the power U times A to the power V. And we know we can simplify this. The base is the same, both the base A. We will add the exponent, right? So that becomes A raised by U plus V. Right? If we multiply A and B, so we get this, A raised by U plus V. So log base A of A times B, we can write it as log base A raised by U plus V. Remember, we have a property. A property is saying if the base in the log, the value can be written as a base, same base raised by an exponent. That's equals to exponent, right? Because if we write in this as y, we have A raised by y equals to A raised by U plus V. That means y equals to U plus V, right? So this becomes U plus V. When the base is the same, right, when the value can be written as in an exponential form, and the base A is the same as the base of log. You see A here, that just disappeared. So we have exponential form, we have log form. We know exponential and the log are inverse with each other. It's like a plus minus are inverse with each other, right? If we plus 2, we minus 2, and if we didn't do anything. Same thing as multiplication and division. If we have a term, we divide by 2, then multiply by 2, as if we didn't do anything. Here is the same. Exponential and the log are inverse with each other, opposite operations. So if we raise the term by in the exponential form, we do for the same base, we take logs for same base, so that as if we didn't do anything to use v. So that's why the whole thing becomes u plus v. And u was written as log AA, right? So we rewrite back in log AA. Then it's the plus log AB. So we know this plus comes from this, right? Comes from this. When we have some base in exponential form, we add the exponents. And whenever we see log form, we know that's the exponents of the base, right? Okay, if you have any question, feel free to stop me anytime. Any questions? Oh, okay. All right, so similarly, we get a second one. If the value is a division, the first one is multiplication. The second one is a division. In division, actually, we can think this way also. So so we have log base A divided by B. We can rewrite as A times B raised by -1, right? Then we can use the first one. The first one is the same. So then we can split this term into log base A, then A plus log base A, E raised by -1, right? If we use the first property. Then that equals to, oh, we didn't talk about this one yet. We have to use the third one, the third property. All right, so this -1 becomes the -1. So let's just write after here. Okay, so log AA, okay, log AA, we can write that this way. Log A divided by B times B, right? Basically A times 1. This 1 is B divided by B. Something divided by itself is always 1. So then we can use the first property, right? If we have multiplication, if the value is multiplication, we split into 2 logs. So we split this into 2 logs. So we have log A divided by B plus log AB. Now we move this log AB to the other side, right? Then we will have log AB, A divided by B equals log AA minus log AB, right? Well, we minus log AB on both sides, right? Then we switch the sides. So get this. So the inside log is product. We split into 2 logs. Inside log is a division. We split into 2 logs, but with a minus sign. So multiplication indicates addition. Division indicates subtraction. It's also from here, right? If we do that, if we b raised by -1, we will have, we rewrite as b as a raised by -v. Then when we add the 2 exponents, we have u plus -v. We would get u minus v. All right, the property in the end comes from exponential form. So let's see C. C is saying if inside the log can be written in an exponential form, then the exponents, exponent C can be moved to the upfront. before the log. So here, the value log of a raised by c with base a. This c can be moved to multiply log. Okay, so we can move the exponent of a to up front, to be in front of a log, to multiply log. Okay, let's see this proof. So we have log a raised by c. A raised by c, remember we read a log a as u, right? So that means a raised by u is a, right here. So let's write a in terms of a raised by u. So we have log base a raised by u, right? Now we have the base is a, this is a, right? u, a raised by u, then raised by c again, we multiply u and c. We'll have a raised by u and c. Now base is a here, and the inside log is the exponential form, also with base a. So log and exponential cancel each other. So in the end, we'll get u times c. Or u just log a, right? Just temporarily use a substitution. So we get a c log a. So those three are super, super important properties or laws of logs. All right, these all come from exponential form. Right. All right, let's use it for some examples. Let's see 8. We have log base 4, 2 plus log base 4, 32. According to the first rule, right? Addition of two logs with the same base. This is base a, this is base with the same base. We can rewrite it as one log and multiply the a and b. So here we have log, so a we have log base 4, so both with log base 4, we then multiply 2 and 32. So we get log base 4, 2 times 32. That's log 4, 2 times 32 is 64. And 64, we can write 64 as 4 raised by 3. Then we will have log 4, then 4 raised by 3. We have log form, exponential form, they undo each other, so we get 3. Let's see the second one. Second one is subtraction. Right? Subtraction of two logs with the same base. We can write it into one log with division. So that becomes log base 2, 80 divided by 5. Well, 80 divided by 5 is 16. And 16 we can write as 2 raised by 4. Once again, we make this log base 2, the exponential form is also 2. So that cancel each other, so we get 4. Let's see the third one. Third one, we have negative 1/3 of log 8. So this number, we can move back to the exponent, to be exponent of 8. Oh, by the way, this log has no base. That means the base is 10. That means the base 10. So we can move this negative 3 to be exponent of a negative 1/3, right? That's the third law. So inside the log, if it has exponent, we can pull outside the log. If it's outside the log, we can pull to be the exponent inside the log. So we rewrite, so negative 1/3 of log a, we rewrite it as log a, so it's still base 10, this is base 10. Yeah. A raised by negative 1/3. Well, a we can write as 2 raised by 3. 3 times negative 1/3 will be negative 1, right? So we would get log half, or log 2 raised by negative 1. 2 raised by negative 1, factor out. So let me write here. They don't have So 2, so log this base 10. Okay, without any base, that's by default, it's base 10. So inside logs becomes -1. Usually we write this as, so -1, we can put -1 in front of log. So that becomes negative log 2. Okay. So log half, log inside half, this half can be written as 2 raised by -1. And -1 as exponent, we can put up front of log. So this is the preferred answer for calculus. All right. So, if you use calculator, that give you estimation, -0.301. But usually we like to keep the value as in the exact form. So that would be negative log 2. And this base is 10. The base is 10. All right. Again, if you have any questions, feel free to stop me. Let's see this example. Right now, we want to use the laws of logarithms to expand each expression. So a is log base 2, 6x. Right, 6 times x inside the log is a product. We can split as addition into 2 logs. So that we can write as log base 2, 6, log base 2, x. Right? So we can write it in this form. And the second one is log base 5. Inside log is also a multiplication. X raised by 3 times y raised by 6. So we can split into sum. We can write as log base 5, x raised by 3, and log base 5, y raised by 6. Then inside the log is in an exponential form. So we can put this exponent of x, exponent of y outside the log. So this becomes 3 times log base 5x. And this one becomes 6 times log base y. Okay, similarly, if we're given this, we can write this into 1 log, right? We can do the opposite. We can write it into 1 log. Let's see the third one. The third one, we have multiplication, a times b. We have also division, right? So this is ln. ln means natural log, log base e. So first we can write as log a times b minus log cubic root of c, right? Because there's a division inside. So write as a subtraction. Now product, we can write as a summation. So have log ln a plus ln b. Then c cubic root of c, that means c raised by 1/3, right? C raised by 1/3. So we can put this 1/3 up front of ln. So that becomes minus 1/3 ln c. Okay. Let's see more examples. If you have any questions, stop me anytime. So this example is doing combining the expressions, the log expressions. So 3 log x plus, right? When we see plus, we can plus of 2 logs. We can write it as 1 log, then multiply inside logs. So we want to combine this into a single log. So first we have this 3 before log. We have this half before log. So we want to put this 3 back to be the exponent of x. Right? So 3 log x, we can write as log x raised by 3. And this half, we can write to be exponent of x plus 1. So that becomes log x plus 1 raised by half. Raised by half is the square root, right? So we have addition of 2 logs. We can write as 1 log as multiplication of the inside. So that becomes log x cubed times square root of x plus 1. Okay. Okay, let's see example 4. So we want to combine 1, 2, 3 terms into a single log. So we have 3 log terms here. We want to combine into one single one. So we see before ln we have 3. So we would move this 3 to be exponent of s. And the second one we have a half in front of ln. We want to move this half back to t raised by half. And we have this 4, we can move back to t squared plus 1 raised by 4. So we rewrite as ln s cubed plus ln square root of t minus ln t squared plus 1 raised by 4. Now we have addition, we have subtraction. Addition indicates multiplication. Subtraction indicates division. So we rewrite as ln s cubed times square root of t minus this term. Then minus means division. So we rewrite ln s cubed square root of t divided by t squared plus 1 raised by 4. Okay, there's some common misconceptions. Log base a x plus y stays as, so if inside log is plus stays, we cannot split them. Only when this is a multiplication. If this is multiplication, we split two logs. If the inside is plus minus, we cannot do anything. Just keep it. Just keep if these two terms as addition or subtraction, we cannot split them. Also, this one, we have a log in the numerator, we have log in the denominator. They cannot be written as log 6 divided by 2. Right? This means log 6 minus log 6 minus log 2. Log 2, right? Let's rewrite this on the side. So let's write here. So log without the base, that means base 10. 6 divided by 2 can be written as log 6 minus log 2. Right? Cannot be written as log 6 divided by log 2. And later on, we're going to see log 6 divided by log 2 can be written as log base 2. And the value is 6. Okay, can be written this way. It's called changing the base. Changing the base. Those two are not equal to each other. Okay. Here we see log base 2x raised by 3. That means we have 3 logs, right? Log 2 raised by x. So this side means we have log base 2 x times log base 2 x again times another term, log base 2 x, right? So this side means log base 2x multiply itself 3 times. That's different from this one. And this one means log base 2 then x be raised by 3 times, right? So this one means log base 2 x raised by 3. Only x raised by 3. But this side, the left-hand side means log base 2x multiply log base 2x multiply log base 2x. Okay, multiply 3 times. So those two are different. Okay, I have Liz is asking me a question here. She's saying she just finished taking an exam, and I was wondering if we were going to present today. Yeah, I'm going to give you a chance to present today, all right? But I need to finish this material to make sure if you have questions. So we're talking about the new laws of today. We're talking about this laws of logarithm. Okay, very important. If the inside log is a product, it can be split into two logs. If the inside log is a division, it can be subtracted as adding a negative term. All right, subtraction of two logs. If the inside the log can be written in an exponential form, the exponent can be pulled up front of the log. Okay, very important laws to use. So just just make sure you are following me up. So where are we? Okay, change of base formula. I don't know why it's not in the laws. Okay, anyway, okay, that's a new one. So this is a changing of base, because we have one example here. So log 6 divided by log 2 is not equal to log of 6 divided by 2. Log of 6 divided by 2 can be written as log 6 minus log 2. And we see log 6 minus log 2 is not equal to log 6 divided by log 2, right? Because one is minus, one is a division. But we can follow this changing of base, right? What's law of forgetting? What do you mean, what's law of forgetting? Rina, what do you mean by that? Law of forgetting on top. Oh, the example 5, the law of forgetting. Don't mind the law of forgetting. The law of forgetting. If a task is learned at a performance level P0, then after time interval satisfy our P log P0 minus C log T plus 1, where C is constant that depends on the type of routine and solve for P. No, let's not mind this law of forgetting. All right, let's mind the change of base formula. Can we? All right, so change of base formula is saying this. Log base B inside log x can be written as log base A x divided by log base AB. So it can be changed to have the same base, log with x, log b. All right. Remember before I had the example log 6 divided by log 2, right? So in both cases, this is log base 10, 6, log base 10, 2, like this. Log base 10, 6, log base 10, 2. So that can be written as log base bx. That means this one can be written log base 2, 6. This is an example showed before. So changing of basis sometimes is important. Let's see some examples. Let's see this example. So let's use let's use the change of base formula and the common or natural logarithm to evaluate each logarithm. Factor 5 decimal places. All right, let's see this one. So log base A5. Let's first understand what does this mean. Let's see y equals to log base A value 5. So that one we can write as the base is A, right? That means A raised by y equals to 5, right? So log A5, what's the value of it? We can think of that means what does this expression mean? This expression means A raised by some power equals to 5, right? So A raised by what power equals to 5? And of course, and also, if we go to calculator, our calculator does not have log base A. Our calculator has log, L-O-G. L-O-G means base 10. Our calculator also has ln. Ln means natural log. It's log base E. So how do we find the value? We need to change the base. So we follow changing base formula. We follow this formula. So log base A 5, we can change it to be log base 10 or ln. Then we can go to the calculator, find the value of log base 10 5, log base 10 8. Then we divide the value, we get this. And the second one is log base 9 20, right? That means what is this expression? That means 9 raised by what power equals to 20? So there's no log base 9 in the calculator. So what do? We change the base. We can change it to be log base 10, 20 divided by log base 10, 9. Or we can change it to be natural log 20, natural log 9. And then, in the calculator, we can find ln 20. And also we can find ln 9. Then we divide to get approximately this value. So that's why we need to change base sometimes. So the formula is, if we have log base bx, we can change into this form with the same base. We can change to be a division of two logs into same base. Let's see more examples. Let's talk about this one. So let's see the graph of log. All right, let's see the graph of log. The graph of log is always goes this way. This is a y-axis. Think about this as a y-axis. And this as axis, x-axis. Right. A log function goes through the common point, right? 1, 0, and goes down as closer to the x value as getting closer to 0, and the y value getting closer to negative infinity. All right. And the top, as x is going bigger, the y value also goes bigger. So this is the graph of log. All right, let's see. Let's try some exercise. So let's see this one, right? If we want to change base, because the calculator does not have base 7, so we can change it to be log base 10, 12. Then divided by log base 10, 7. Okay. So let me find some so you could try it. So evaluate the expression. Okay, let's try a couple of this. Let's try. Let's try 7 up to 7, 8, 9, 10, 11, 12. Okay, let's try 7 to 12. Try 7 to 12 in this one. Then I'm going to leave you some homework. So homework number 10, right? Homework number 11. Homework number 11. Thank you. Thank you. Give me some homework. Okay, so you try 7 up to 12, all right? Then you can present. Let me think about the homework. Okay, 11 up to 18. Try 7 to 12 also. Also 45 to 48. Oh, those ones are good too. Okay, let's just try. Let me not put too many. Then many of them we're going to try. Okay, let's just try 7 to 12 first. 7 to 12. Okay, let's try this. Come on first. Yeah, Sarah, when I finish, all right? When I finish assign homework 11, I will do that. I always post the homework on the Blackboard, so you can also check the content on the Blackboard also. But for now, please try 7 to 12. All right. It's really important to understand the material, to learn the material, other than try to worry about finish homework. You can always find the homework set on the CUNY Blackboard. Okay, are we done? 7, 8, 9, 10, 11, 12. Almost. All right. So let's say 2 more minutes. All right, just follow the rules. Just practice the rule. Okay, let's see. Anna, do you want to try 7? David, you want to try 8? James, 9. Jeremy, 10. Elizabeth, maybe 11. Natalie, 12. You don't have to write it down or present or something. You could just talk about it. Anna, can you hear me? It's okay. It's okay. You don't have to be, totally correct for this one. Little bit confusing. That's okay. We will talk about it. Okay, but just show how did you understand? How did you do it? Okay, Anna, are you here? I see Anna's name on the list. Okay, David. David, are you here? David? James? James, I know you are here. Okay, let's start with you. You want to show 7? Can you explain 7? We're here to learn, okay? It's okay to make mistakes. According to the rules we learned, right? How do we find the answer for 7? All right, because Anna is not replying, but a couple more people, the people ahead of you, Anna is not replying, David is not replying. So I'm just go through the list on the chat. Attendance. Is it possible you could talk about James? You can talk about the 7. Oh, okay. You only want to do 9. That's okay. Talk about 9 then.
Professor, can you hear me?
Yeah, I can hear you. Go ahead.
Can I skip for can I pass? Can the others go first? Because I'm still actually understanding how number 9 became the answer number 2. I'm still a bit confused because I arrived late at the class. So
Okay, that's okay. Yeah, all right. Let me call other people.
sorry about that.
I'm just going down the list. Okay, maybe Jeremy. I know Jeremy can do all of them, but let's just do one first.
I'll just do. Can I just do 10?
Yeah, go ahead. Do 10.
Okay, so for 10, I knew that it being a radical, it's gonna turn out to like be a negative. So log of 1 over radical 1000. Ended up getting um I ended up getting 10 to the negative 3 over 2,
Okay.
and which gave me log of 10 parentheses 10 to the power of negative 3 over 2. And yeah, I just got negative 3 over 2 from there.
Okay, that's great. So let me just write in the chat. So far, you're doing great. You were saying the cubic root, the square root of 1000. 1000 can be written as 10 raised by 3. Just type it in the chat. Then you see square root of that. Oops, I'm missing one zero in the chat. 1,000 can be written as 10 raised by 3. The square root of that 1,000, 10 raised by 3 can be written as 10 raised by 3 halves. Then, because we have 1 over square root of 1,000,
Be negative.
that can be written as 10 raised by negative 3 over 2. That's great. Okay, that's why you can write the expression as log now. Log of 10 raised by, oh, I'm sorry, the chat have so many mistakes. 10 raised by negative 3 over 2. We have done so far. So one more step, two more steps. Okay, the log has no base. If log has no base, what's the base? By default.
10. Yes, 10.
10. Yeah, so that's base 10. So what happens when the log has the base, with the base for the log, and inside the log, the value can be written as the same base raised by a power. What's the rule?
It's not 1, right?
No, it's not 1.
Okay.
You can see in the chat log base A. If the value can write as A raised by B, that equals B.
Okay. Right.
So can you finish your 10? The base of a log is 10. And inside the log is 10 raised by negative 3 over 2.
Yep.
So according to this rule, what should be your answer?
Yeah, negative 3.2.
Negative 3 over 2. Great, that's it. Anybody has any question for 10? 1 over square root of 1,000 can be written as 10 raised by negative 2 over 3. Then the value is base 10 raised by negative 3 over 2. The log is also base 10. So by this rule, let me just show you one more time. By a property we talked about last class. Yeah, log without any base is base 10. Look at 3. Inside the log can be written in an exponential form, a base raised by something. Then this base has the same base as the log. So this is log base A. Then inside the log is also base A raised by a power that equals the power. Because why? Why? So if we rewrite this in an exponential form, we would have A raised by X equals to A raised by X, right? That's why this rule is true. So here we have log base 10, and the inside the log is 10 raised by negative 3 over 2. So that's why we have negative 3 over 2 as an answer. So let me write here. That equals to negative 3 over 2. Anybody has any question for this? Is this still confusing? All right, let's try next one. So who wants to try next one? Anybody wants to try 7? Or Natalie wants to do 7. Go ahead, Natalie.
Hello, Professor. Can you hear me?
Yes.
Okay. So for 7, I changed root 27 to 1 out of 2. So like log base 3, 27 to the power 1 out of 2.
Okay.
And then I expressed 27 in terms of 3. So log base 3, 3 to the power 3 times 1 out of 2. So like log base 3, 3 to the power 3 out of 2.
Great. Okay, then so need one more.
Yeah. And then since log base 3 is 1, I just bring like the exponent to the front. So 3 out of 2.
That's it. Perfect. Great. Okay. Anybody has any question for this? Natalie is saying square root of 27. 27 can be written as 3 raised by 3. Square root of that can be written as risen by half. Then 3 times half is 3 halves. So square root of 27 can be written as 3 raised by 3 halves. So then the log base is also 3. We use the same rule we talked about before for 10. So the answer for this is 3 over 2. All right, let's see. So 7. Anyone wants to try 8? Okay, and James, are you ready for 9?
I think so.
Okay, let's go.
Okay, so in my understanding for number 9, it's basically we're following the first law of logarithm, basically the multiplication one. So log 4 plus log 25 will be written as log 4 times 25. That's gonna be 100. So after that, that's gonna be like the logarithm base 10 of 100 is 2. So our final answer should be 2. That's what I understand. I'm not
Yeah,
so not
I
sure.
think you did it right. You did it right. You will see, I see an addition of 2 logs that have the same base. Can you tell me what the base of the log?
10?
10. So both of them have the same base 10. So if the addition, that means I can multiply the 2 values inside log, become 1 log. So that
Oh,
becomes log base 10, 100. 4 times 25, 100. And the 100 can be written as 10 squared.
mm,
Then again, we have log base 10, 10 raised by 2.
mm.
We use the same log law, so that equals to 2. All right, great.
Question.
Yes. What's your
Why did it become log 10? Like, so if there's no number in the base, should it be equal to number 10 immediately or in some special cases only?
I'm sorry, I did not understand the question. Can you repeat?
Oh, sorry, you said there's a log 10 here in the 4. Where did 10 come from?
10 is by default.
Oh,
When you see log has no base, it's by default. That's just a convention.
oh,
Yeah, when you see no base, that's base 10.
okay, okay. I think I get it. Thank you, Professor.
You're welcome. When you see in the calculator,
Mm-hmm.
you will see log, L-O-G, L-O-N. The calculator only has 2. L-O-G, that means base 10. L-O-N,
Oh,
that's base E.
mm. Okay. Thank you, Professor.
You're welcome. Okay, Rina wants to do 8. Go ahead, Rina, 8.
So I didn't take a picture, but I can talk about it.
Yeah, talk about it.
So for 8, I put 160 and 5 together from the second law. I think it was the second law, and then it's log base 2, and then 160 over 5. So that's log base 2, 32. And then for log base 2, 32, I made it equal to 0. I mean, not 0, equal to x, because I was looking for what, like 2 to the x equals 32. So like 2 to the x equals 2 to the 5, because I made them the same bases. So then since the same bases, x equals 5.
Okay, all right, so yes. So we see subtraction of 2 log with the same base, because both base 2. Subtraction means we can divide the values inside log. So we do 160 divided by 5. So we get log base 2, 160 divided by 5. 160 divided by 5, we get 32. 32 we can write as 2 raised by 5. So this whole thing becomes log base 2, 2 raised by 5. By the same law, we get 5. Okay, we have 2 more, I guess, 11 and 12. Anyone wants to show 11 or 12? Samir?
I think I can try, but I'm not 100%.
Elizabeth? Yeah, go ahead.
Yes.
Try. Which one you want to try?
11. I don't understand completely yet, but I can try.
Okay, let's go. Let's try.
Okay, so as the last one, since we are doing subtraction, we are going to be dividing 192 by 3. Okay, 2 by 3. Okay, so it can be written. I know that the result is equal to 3, but I mean x equals to 3, but 192. Yeah, wait, give me a second. So yeah, okay. So if you want to help, you can go ahead, since like that's basically what I understood as of now. So
Yeah.
since it's
But your answer
subtraction,
is
we
right.
are
Your
doing
answer is right.
division.
Let's see why. Let's see why. Okay.
Okay.
So we have same. Can you tell me the base of the log?
Yeah, it's 4.
It's 4, right?
Same for, yeah.
And both have the same base, right?
Mm-hmm.
And it's subtraction. Subtraction tells us what can we do?
Division.
Division. So then 192 divided by 3, what do we get?
64.
64. Can we write 64 in exponential form with base 4? Because a log has a base 4. We can write 64 as 4
Yes,
raised by something.
4 raised by 3.
4 raised by 3. Now, log base 4. And the inside, we can write as base 4 raised by 3. We can use the law again. The law tells us this is 3, right?
Yes, x is equal to 3, and the
Right.
log is the same as 4.
So the whole thing equals to 3.
Yeah.
Right. Okay.
Okay.
David wants to try 12. David, go ahead.
Okay, hi.
Yeah.
So I'm not sure if it's right, but I think I brought down the 9 and 16 and multiplied it to get log 12 144.
Okay.
After multiplying 9 and 16 and then the base of 12 and 144, I got 2.
Right. So you will see the both logs has base 12. Then addition, that means we can multiply 9 with 16. So 9 times 16, we get a 144. So now you have log base 12, 144. So so 144 we can write in an exponential form with base 12. 144 equals 12 raised by what power?
12 by 4.
144, right? 144. We
Yeah.
want to write 144 in an exponential form with base 12. So 144 equals 12 raised by what power?
2.
2, right?
Yeah.
So now we have a log base 12. Then inside the log is 12 raised by 2. So by the log, we get 2.
Okay.
Right?
So yeah.
Okay, looks good. Looks good. Okay, anyone has any question? Good. We're doing good here. Okay, now let's try another bunch. Let's try not a finding value, but let's try 21. So this is the use of the laws of logs to expand the expression. Okay, product we want to split into addition. Division we want to split it into subtraction. All right, let's try 19. Okay, let's try these guys. 19, 21, 23, 25, 27. All right. And also, if the exponent, we can pull up front of the log. All right, so let's try this 5. Math is all about trying to understand. After we learn the definition, we learn the practice. The rest is just keep trying and trying. And learning, making mistakes is part of the learning process. Okay, I think we're doing great here. Excuse me.
Professor,
Yeah.
I was wondering if we are not presenting today. Because last time I was in a rush and I couldn't complete what I was explaining, or I didn't show the word correctly, so I don't think I earned or you gave me points for it. So I want to do it today.
Oh, yeah.
Okay.
But can we finish this 19 up to 27 first?
Yeah, of course.
Okay.
Sounds good.
Okay. Okay, Tijeda, are you here?
Yes, I'm here, Professor.
Oh, okay, great.
I just
Okay.
got here a few minutes ago. Was taking an exam. That's why. So I wasn't here for the lecture. I was just listening for the explanations and stuff.
Oh, okay, that's good. That's good.
Yeah.
All
Is
right.
it possible to present what Lisbeth was talking about? The homework number 9.
Yeah, let's talk about this. So this is a new material. So far, are you
Okay.
picking up the new material? We're talking about some new properties. Like
Okay.
this.
I will have to listen to the lecture.
Okay. All right.
Yeah. Thank
All
you.
right. You're welcome.
All
Samir,
right.
are you here?
Yes.
Oh, okay. All right. So you are here for a while, right? You listen to the
Yeah, of
we'll talk about
course. I've been
right.
listening.
But I'd like you to try one of those questions.
I'll probably do 19.
Okay. All right.
So for 19, so we have a log 2 over 2 to the x. So what I did was I rewrote it as 1 plus log of 2 over the x parentheses.
Yeah. Yeah, you're right. But you skip some steps. Can you tell us what you did?
So what I did was I took the 2 of x, then I moved the 2 base of 2 to the bottom of the after the log, then I put x by itself.
Mhm. Yeah, your answer is right. Let me read for you.
Okay.
So you have log base 2, then inside the 2x, right? You said that equals to 1 plus log base 2x, right?
Yeah.
Right, the answer is right. You have to explain to us why. Because you have 2 times x, right? Product inside the log. That means by the laws we learned, you can split into addition of 2 logs. So let me add the intermediate steps. So you split, how do you split?
I took the log of 2, and I split the 2 to the 2x, and I moved the 2 to this spot. So that means we had 1, then move the 1 over to the the first place before the log.
No, you still haven't taught. I need a very important intermediate step. So the second step, right?
Mm-hmm.
You see the product of 2x. So right away you split into addition, right?
Mm-hmm.
What's the addition? Which two terms you're adding up?
Which two terms? I think it's 2 to the, hold on, 2
Log base 2.
to 1, or is it 2?
So, you were seeing log base 2, right?
Yeah, 2.
Okay. Then the second term is, the second term is log base 2
to the 1.
to the 1. Why?
I meant 2, sorry.
You already have that, right? You already have the first term log 2. The
Oh,
value is
I think I know why it's 1. Because it's dx is what's left.
right. So the
Yeah.
second term is log base 2x. Right?
Yeah.
You see the product of 2x, so you split into 2 logs, addition of 2 logs. So the first one is log base 2, 2. The second one
The
is
second
log
one?
base 2 x. Then what's log base 2, 2?
2.
Log base 2, 2. Log base 2 with a value 2. Log base 2 of 2.
Mm-hmm.
2 raised by 1 equals to 2.
2.
So that log base 2 of 2 is 1.
Mm-hmm. Yeah.
So that is equal to 1 plus log base 2x. Okay. All right, good. Let's see. Anna, yeah, Anna, can I hear her? Okay, anybody wants to try the rest 21, 23, 25, 27?
Okay, so it's like only to expand it. We don't have to solve it basically, right?
We cannot solve.
Okay. So let me see. For number 23, what I did is it's log 610, and for that log, it's like it has like okay, so to convert it or to basically express it in other way, it has to be the exponent would be placed before the log, and the x will and the log a, I mean the log and its space and the number will stay the same. The only thing that changes is basically the exponent. So what I did was, it says log 6 raised to the 10. Since there is no number with a log, we know that by default is 10. So we say since the exponent is 10, we put the 10 behind or before the log. So it's going to be 10 log um, log 10 and then 6. That's it basically.
Exactly. Yes. The
Okay.
only thing we can do with this one is move the exponent of 6 up front of log. So that becomes
Yeah.
10 log 6. Log without any base, just base 10.
Mm-hmm.
6. Okay, great. All right. Okay. Oh, Natalie wants 21. Go ahead, Natalie.
Yeah. So for 21, you have to expand x and x minus 1. So it's going to be log 2x plus log 2x minus 1.
That's it. Yeah. So this 21 we can write as log base 2 x plus log base 2 x minus 1. No, better we put an absolute value sign there because we want the x value to be inside log, cannot be negative. Okay, great. That's it. Okay, anybody else wants to try? Tijeta, you want to try one? So the rule is if we see inside the log is product, we split it into 2 logs. If we see inside the logs in an exponential form, we pull out the exponents up front the log. If we see the division, we split into 2 log with subtraction.
Okay, so 25. Basic explanation I could try because it's an exponent.
Yeah, let's try 25.
So the exponent 2 will come down as 2 log 2 AB.
Do we want to do exponent first? Because A does not have exponent, only B has
Yeah,
exponent.
only B, yes.
So should we deal with exponent first, or should we deal with the product first?
At the product first.
Yeah, let's do the product first. Then what do we get?
So that will be log 2.
Log
I'm
base
not
2.
really sure. Yeah.
Oh, if it's a product, we split it into summation of 2 logs. So we split it into,
So the A goes in different way and the B to the second go to a different way, right?
that's right. So we
On
rewrite
A
as
plus B square.
log base 2 b squared. Then now the square, the 2 can pull up front the log with b.
Okay, so it will be 2 log. So it will be log 2A plus 2 log 2B.
You see that? You see why? The 2 is only
Yeah, I kind of see it because since the A and B is a product, when you
right.
split it, since A doesn't have an exponent, that's just A by itself.
Right.
And then you add it to log 2 B because
Right.
of B have a square of 2.
Exactly.
And then you bring down that square in front of the log.
Exactly. Right.
Okay.
So that's why we cannot, if A, B both being raised by 2, maybe we pull the 2 up front first. But here, A does not have exponent. Only B has
So
exponent.
if it was to be like numbers, let's say like 5 and 10, same rule will apply, right?
Yeah, same thing. Yeah, A, B
Okay.
variables. All right.
All right.
Anybody else wants to
Thank you.
try one? Okay, Rina, try 27. Go ahead. Oh, you want to present it? Okay. Oops. Rina, right here. Sarah wants to show your work too, right?
So for 27, I can expand them out with the addition because inside it's multiplication. So it's log base 3x plus log base 3 square root of y. And then since the square root of y, I can make it 1 over 2. So for log base 3x plus 1 over 2 log to the 3 y, because I can take the square root to the outside of the log.
Perfect. Perfect. Anybody has any question? All right, the homework. Yeah, let me write down the homework in the chat. And also, Sarah, you want to present one of your homework, right? 13 to 18. So this is a 4.4. Already put on the enter the content on the blackboard. So 13 to 18, 39 to 44, and 49 to 52. Okay, logs are, like very strange notations, but once we get used to it, we'll know how to deal with it. All right, if you have a question, you can stay behind. And if you have no question, you're free. And I'll see you on Friday.